Okay? All right, lights, camera, action. All right, so here we are. Today is Friday, March the 14th. Yes, we got one more week before spring break. All right, so today is our last day to talk about electrochemistry. On Monday, we're going to start in talking about acids and bases. And the goal is to get just enough covered to where at least we have an idea for this mock exam, which we're going to take on Friday. Again, what day are you? You're not here Wednesday, Thursday, or Friday? Yeah. Spring break wasn't long enough. We had to add a few more days onto it. Yeah. Okay. Yeah, I don't know what I'm going to do with that. So, but the rest of us are going to take the mock exam in class on Friday, and that's where we'll just have all of 5th and 6th. What did we say we were going to do? We're just going to ask Stamper to get out of the 4th period early, right?
Like 20 minutes early.
So you go to lunch, and then you come here and have all of 5th and 6th. Okay, so that's the plan. So I got to talk to Stamper for 4th period. Okay. So when we're looking at this is kind of where we were yesterday. So I know that we are at the end of the day, and you might have been fading out a little bit, but I want us to kind of just finish the thought and then look at several more practice problems today and make sure that we're comfortable doing all of these types of problems. To me, this is pretty straightforward. There doesn't seem to be as many curveballs or stumbling blocks on these as there were in some of the other units. Okay? So when I'm looking at this, we write the balanced equation. Now, how again did we know which one was being reduced and which one was being oxidized in this?
Well, you said deposited solid.
Okay, so it's saying deposited solid rhodium. What else?
And then oxygen gas is being produced.
Oxygen gas is being produced. A third factor is that this is electroplating, this is electrolysis. Electrolysis is when we use electricity to make a reaction that doesn't want to occur. We're forcing a non-spontaneous reaction to occur by putting energy in. Okay? So you want to say, well, this has a higher reduction potential, so it seems like this ought to be reduced and this ought to be oxidized. However, we're making it go the opposite direction. So write the balanced equation. So I know that this one is going this way, this one is going this way, but what did I need to do after I do that? What did we do to get the equation balanced?
You have to multiply it by 4.
I had to multiply this one by 4 and this one by 3 in order to get 12 electrons. So it was 3, 12, 12, and 6. And this one is going to be 4, 12, and 4. And then we added them together again, this one coming this way. So we ended up with 4 RH, 3 pluses, plus 6 H2O liquids. Okay, goes to, I should have moved this whole thing up higher, 4 RH solids plus 4 3O2s and 12 H pluses. And y'all, my brain is foggy today due to y'all, giving me this, wonderful head cold. So I've made a ton of mistakes in 4th period, so you got to keep watch on me. Okay, so feel free to correct at will. All right, so there's my equation. Then calculate the value of E cell. Well, E cell for 2, it's always going to be, E cell is always going to be E red minus E ox. So it's going to be what thing is being reduced? The top equation and the bottom equation is being reduced. The top one, okay, even though it's the smaller, so it's going to end up being 0.8 minus 1.23. So the value is going to end up being a negative 0.43 volts. What does the negative sign mean? It's not spontaneous. It is not thermodynamically favorable. It's not going to occur, really. This reaction doesn't want to occur. The right to left is really what wants to happen. right to left is gonna be the positive 0.43. So then, the next question on the back of the page says, well, based upon your answer here, why do we need a power source? So what, okay, because it's non-spontaneous, so what, again, we need a little bit more than that. So what do we wanna say?
It's not spontaneous, it requires an energy source to make the reaction occur.
That's perfect, now say that so they can hear it in the back.
The reaction is non-spontaneous, so it requires energy to make the reaction occur.
Okay, I could not say it any better than that. So now we didn't really have time to do that last one, but you should know how to do the last one. So let's take 2 minutes and just complete that last one as well. Go ahead and pause the video, please. So we got 2.8 grams of rhodium on a piece of silver. So from the previous prompt on the previous page, we know that the rhodium is being plated out. Okay, so it's still going to go here. So we're just going to start with the 2 grams, convert that to molar mass, 1 mole, and what did we say it was?
Would it be 2.8 grams?
Oh, I'm looking at the wrong thing. Yes, I'm telling you, got to keep me straight today. My brain is foggy. 2.8 grams, and the molar mass was what?
102.91.
Okay, so now I have moles. Okay, moles of rhodium. Okay, so how do I go now? What do I need next?
Moles electrons.
And that's N. And I get that from here. It's just this 3, and always whatever the positive charge is, the 0. So I'm going to say 3 moles of electrons for every 1 mole of rhodium. Okay. Now what has moles of electrons in it? The Faraday. So I'm going to say 96,485, and again, that number is given to you. Coulombs. Now the official, they use a big C for coulombs. I mean, as far as AP, I like to write it out because C to me means so many different things, the speed of light and all that. It's hard to tell a big C from a little c. So I just write it out over 1 mole of electrons. So moles of electrons cancel. So now what has coulombs in it? Now, what's another way they could have given this to us?
Amps.
Just amps. It could have just been an A. Okay? So that's the first time I've ever seen them give it in terms of coulombs per second rather than just amps. So we should know that an amp is a coulomb per second. So we want coulombs on the bottom, so I'm going to say 1 second over 2.0 coulombs. And again, I do write SEC out versus just S for second. You know, maybe it just SEC means more to me, but it's just, to me, again, I get lost with just the single unit. That's my own personal preference. S for seconds is 100%, and that's what the normal is. All right, so all of that comes out to equal how much? 2 sig figs. 3,900 seconds. Okay, and we all are capable of converting that to minutes or whatever if needed be using 60 seconds in a minute, 60 minutes in an hour. I think that's all things that we all know. All right, so that is just kind of a real, just a gist. That was last year's question, number 7, a 4-point question. On a scavenger hunt, that's an easy 4 points right there. Okay, you only need 38, you know, and you can do random guessing, you know, out of 60 questions. You know, you get 25% right, just random guessing. That's 15 points. Plus 40, you're at a 19, you're halfway to a 3 right there. Okay? But hopefully we're not going to randomly guess on our multiple choice. Okay. So now, let's look at, I don't have this one for you, but let's just kind of look here at this one, because this is year 2014. Okay, now I'm just going to move it up to here, and I'll pull the screen down. Okay, but let's just look here. So on this one, they don't really give you any numbers. But it says a student is given a standard galvanic cell represented above that has a copper electrode and tin electrode. As current flows through the cell, the student determines that the copper electrode increases in mass and the tin electrode decreases in mass. Identify which oxidation is occurring and explain your reasoning based on the student's observations. Okay, so take 30 seconds, a minute, and just think about what you're gonna get.
The SN is getting oxidized
Okay, and how do you know that? That is 100% correct.
because it's the copper. Yeah, copper is gaining mass, and then in the aqueous solution, it's 2+. So
Okay, so again, you just said that. So in this aqueous solution here, we know it's Cu2 plus here. So what's happening to it?
it's getting reduced.
So it's going here, right? So what's happening over here?
It's, the SN is going into solution.
So the SN is coming into solution. Okay, very good. So therefore the SN is being oxidized. So what electrode is this going to be then? Somebody else. Okay, it's going to be the cathode because this is where reduction is taking place. Okay, because this is being reduced. Okay, this is being oxidized. So this is the anode. So where's the mass go? So it says, as the mass of the tin electrode decreases, where's the mass go?
In the solutions.
Which is, it's coming into the solution. This mass is not going onto the copper electrode. The tin is going into here. Now the last question says, there's an expanded view of the salt bridge. And what's going on in the salt bridge? So let's just look here at the salt bridge. Okay, the salt bridge is KNO3. So given this, what's happening in the question asks, it says, in the expanded view of the center portion of the salt bridge, shown in the diagram below, draw and label a particle view of what occurs in the salt bridge as the cell begins to operate. Omit solvent molecules so you don't have to put water. And use arrows to show the movement of particles. So what, if this is my salt bridge, what's happening in the salt bridge?
The ions are going into
Okay, but specifically, which ions are going which way?
K is going to the left, and then the 3 is going to the right.
Okay, K plus
Okay.
is coming in here, and NO3 minus is going in there, right? Because SN2 plus is coming in, so this is becoming more positive. So what's the function again of the salt bridge?
Make it neutral.
the solution neutral.
Okay, to allow ions to flow to keep the solution neutral. Okay, you might want to always mention, it allows ions to flow to maintain electrical neutrality. Okay, so because this is becoming more positive, the NO3 minus has to go here. Because the Cu2 plus is leaving, the K plus has to come in to replace it. All right, so which way are the electrons flowing?
Up through.
Clockwise or counterclockwise?
Counterclockwise.
Counterclockwise, right? So the electrons are going to be here, they're going to be going this way. Electrons coming this way. So that's really all you have to know as far as the diagram is concerned. Okay, the mass is, where it's being reduced, it's where the mass is going to increase. Where it's being oxidized, the mass decreases. Okay, we all good with that? Okay, very common questions. Okay. So now, I just gave you another sheet. So let's take, it's the two parts, a front and a back. Let's take 20 minutes or so and really try to see what we can do with that sheet. Okay? All right,
A new one?
you have a new one.